without further ado, then we can just go ahead with the next session, which will be related to the operations and the general process improvement using AI and AI-driven digital transformation. So we have a range of speakers today from university and from industry, and that will be Neslihan, who from Leicester Innovation Hub, who will be leading this session. So I'm just handing over to Neslihan now.
Thank you. Hi everyone, I'm Neslihan Suzen. I'm Data Analytics and AI Innovation Fellow. I'm very pleased to introduce the next couple of segments of this session, which will give both insight and inspiration. So these will be meeting our digital innovators and talking about the use of data and AI-driven digital technologies, how the research is being applied, working with businesses, and digital breakthroughs from our industrial collaborators. First, Professor Ashiq Anjum and Dr. Frank McQuade will be sharing the first session. Professor Ashiq is a professor of distributed systems at the University of Leicester. His areas of research include data-intensive distributed systems, distributed machine learning models, AI-driven digital twins, and high-performance analytics platforms. He is closely working with industrial partners, including healthcare providers, hospitals and pharma companies, rail companies, VR providers, and automotive and logistic companies. And Dr. Frank is Director of Capability at Bloc Digital. He is a business leader, a technology developer, and professional engineer having 20 years of experience in the field of advanced engineering and digital capability. They will talk about AI and digital twins, the use of cutting-edge data and AI-driven digital technologies, and how their application to business promotes growth and productivity. So thank you for being here today to share these insights and project impacts. And the second segment of this session, Dr. Alberto Paganini, who is an academic in the School of Mathematics and Actual Science in the University of Leicester, and a lead academic in Leicester Innovation Hub, will share details of opportunities within departments, case studies of our students and graduates working with businesses on projects. We are delighted that Kevin Routledge, who is chairman at Leicester Riders and director at Morningside Arena, is part of this session and is joining Alberto to share Leicester Riders journey, their digital journey, along with their digital breakthroughs with collaborating with the University of Leicester, and give insight into responding digitally to COVID challenge. So next for me is to welcome and hand over to Ashiq and Frank to get started with sharing their session.
Okay, so thanks for the nice introduction. So for next few minutes, I would be going through the process and some of the projects that we have been working on, AI and related aspects, and how they are helping different businesses and a kind of applications to transform. So I would start with the introduction, and then I would hand over the control to my colleague, Dr. Frank McQuade, who is a Director of Capability at Bloc Digital. So I would start with the fundamentals or the drivers of AI-driven digital transformation. So essentially, there are 5 drivers of digital transformation. So artificial intelligence comes quite late in the whole kind of ecosystem. So we have to start with a kind of a data-driven distributed system so that we can actually propose the systems before that system could be used for advanced AI analytics. So so the fundamental drivers before we start with AI are essentially distributed systems and high performance computing. So and essentially the system sides with that behave or that kind of promote the use of data essentially in terms of processing or in terms of analytics actually. So once we have the underlying system, it could be cloud systems or it could be HPC systems, then we use integration and modeling actually for the data that's being stored within these distributed distributed systems. And once our data has been modeled and integrated, then actually we use AI, and AI has different types actually. So either that could be real-time AI that's working close to the data sources, or it's essentially a distributed machine learning that works within either the data centers or in high performance computing facilities. So I would be explaining all these kind of steps as I go through different applications. So the feature applications that we have selected for today's talk are essentially 4 different areas. So I would be discussing a couple of projects from Edge AI, and they are related to security and transport. Then I would be briefly touching upon Graph AI, and that aspects are essentially applied to healthcare applications, especially genome analytics and personalized medicines. I would be briefly discussing that how essentially trustworthy systems or security aware applications are making use of AI, and essentially that's our blockchain. And then I would be handing over control to Dr. Frank McQuade, who would be discussing how AI has been used for production of digital twins and eventually their operations as well. So before I start that, how a kind of IoT is making use of AI. So first we need to have a general perception or definition of AI, and that how basically a kind of underlying systems are working. So here, the first thing is that what is the Internet of Things actually? So Internet of Things has very a kind of diverse kind of range of definitions and kind of interpretations. But the simplest one is that where the digital world meets the physical world actually. So it could be smart cameras, it could be smart cars or smart homes, or it could be other aspect of smart cities where the physical and the digital worlds is coming together, and we say it's Internet of Things actually. So, and as we know that the future of the data in terms of both production of the data and consumption of the data would be driven by IoT applications. So I found some numbers from a Cisco reports. This is that they in next kind of decade or next few years, they would be generating 6,000 exabyte of data. So it's a kind of 1 exabyte is 1,000 petabyte, and 1 petabyte is 1,000 terabytes actually. So you could see the scale of the data that IoT applications would be generating. So, and today we could only generate essentially 12%. So remaining 88% is a kind of not processed due to many reasons that I would be explaining. For example, in this one particular project that we did with a particular company that's based in Bristol, and they work with different law enforcement agencies. So here, for example, UK, for example, has almost 6 million cameras. There is one surveillance camera for so for every 11 people actually. So now if they start sending data to cloud actually, just my slide is a bit okay. Yeah. So if they start sending data to a cloud, this is beyond the capacity of any cloud to kind of absorb that data or process that data. So what we did was that, this was the first generation of the projects. It was almost 10 years back actually. So we were kind of capturing the data right from the camera streams or the video streams or the camera sources, and then sending that data through basically different kind of intermediary layers to our cloud. And then we were using AI actually. And at that time, this convolutional neural network was quite new actually. So we were using convolutional neural networks, and on the server side, we were using kind of Spark clusters because that was in-memory processing. We were using a kind of OpenCVs because that gives us the image processing capabilities. We were using GPUs to essentially parallelize the processing process, and then more or less within 2 minutes we were trying to process the streams that were arriving in the data centers. So probably you could remember there were riots in London a few years back, and it took police and law enforcement agencies almost 2.5 years to simply kind of put together the evidence because all the process was manual. So essentially now what we could do is any data stream that's coming, essentially the video streams here we're talking about, we could process that through automated algorithms or AI algorithms. algorithms, and the people sitting in the control rooms, either they're in the airports, in the smart cities, or other kind of logistic companies, they don't have to manually process or look into those video streams. Now, there is a challenge. There is too much data actually. So if we start capturing all the data that these video streams or the video cameras are capturing, no amount of storage would be able to absorb that data. So we need to find a way to essentially process the data at the source so that we should not bombard the cloud data centers or HPC facilities with a lot of data. So on this respects, what we did is we started exploring the use of Edge AI almost 7-8 years back, and we started writing papers. So what Edge AI is that instead of sending all the data to our data centers, we process the data on the edge actually. For example, camera would become intelligent camera. So let's suppose if there are 6 million cameras, all of a sudden we can convert those 6 million cameras into 6 million computers that are distributed all across the countries, for example. So, and if there are routers and switches in between them, we could push forward some of the computation on these in-transit nodes actually. So the future applications would not be sending data to the cloud, rather would become basically Edge AI sources or Edge AI hubs, what we say it's. So essentially, all those IoT devices that are producing data would become basically the consumers of the data on one side, and essentially the intelligent devices that are essentially not only producing data, rather they are processing the data in itself as well. So for example, in the future applications, it could be science experiments, it could be smart grids, it could be smart cities, it could be genomic machines, for example, the driverless cars, VR, AR-enabled digital twins that Dr. Frank would be explaining, or any other aspects of a 5G enabled app, because they have the similar rates, and they would be benefiting from Edge AI if we start processing the data on the IoT devices or on the sensors that are producing the data. So, for example, one of the projects that we are doing with a company in Derby is a Fishbone Solutions, and we are using Edge AI for real-time condition monitoring and predictive maintenance. So this is a knowledge transfer partnership with a local rail company, is basically the end users there. So what they are trying to do is, so we have deployed sensors on the trains, and they are based on the vibrations and a kind of pressure and other kind of aspects that they're monitoring. And so we are trying to make those sensors intelligent and pushing some of the intelligence that we have trained within the data centers on the edge actually. So now, for example, sending all the data, there are millions of streams every minute. So previously they were sending millions of streams. Now what will they do most of the processing on the source, and only useful evidence and information is sent to a data warehouse actually. So we have used make use of a kind of distributed frameworks, for example, Spark. This is open source framework, and then we have built a dashboard so that we only know what are the important events that a company or infrastructure provider should consume or understand, instead of kind of have to go through millions of streams that different kind of components or different kind of moving parts sending to data centers. So this has enabled a lot of different companies to kind of extract and propose newer applications, because now we could monitor the infrastructures as it is in operations, and instead of sending all the data to our data centers, we only bring in the streams that are of interest, and we do most of the processing at the edge. So this is one of the applications of Edge AI, one that this is for real-time predictive maintenance and condition monitoring, and that could be used in, I mean, beyond train and a kind of manufacturing as well. So, and the second area of AI that we have been exploring is essentially graph learning, and the use of AI to inform or make the graph systems intelligent, and that applications have been in transport and health, and I will be quickly going these two aspects. So, for example, this is you could see this is a kind of a snapshot of a UK rail network actually. So. And the delays are quite a common problem. So 1 minute delay that leads to more or less more than 100,000 pound actually in value to different stakeholders. And there are almost 3.6 million passengers hours are lost in delays across the network. So the problem was that how can we use a kind of intelligent AI and related approaches to kind of cut down the delays, so that when there is a kind of accident, or when there is, for example, a network issue, or when there is a signaling issue and train is delayed, how can we minimize the impact of that delay across the network? So as a first step, we converted that network into a graph models. And on top of that, we have been using AI to classify the impact. And then we say that, by the way, this is a low impact incident, this is a high impact incident. So the impact was in terms of the delay propagation. If, for example, if it's 5 minutes delay, we would give it a different class. And if it's a half an hour delay, we would give it a different class. And then we would try to basically marginalize it, or squeeze or minimize the impact, so the impact does not propagate to the rest of the network actually. So using that approach, we have been able to identify that how not to only minimize the impact of a particular incident, rather we should also be able to find alternative routes, so that if we are wasting 5 minutes or 10 minutes on a particular segment, so how that train or particular engine, for example, could be transported onto a different segment, so that we could recover the lost minutes actually. And we have been a kind of 80 to 85% successful in that, because we not only minimized to significant extent actually the lost minutes, but at the same time we were able to find alternative routes. And by the way, this is not happens in retrospectively, this is more or less happening in real time. As the data is arriving, we are able to basically reconfigure and propose alternative routes more or less in real time actually. So that was the health side. And similar aspects, for example, the same approach we have been using for genome processing as well, for the personalized medicine. So we know that previously, for each kind of, for example, if someone has blood pressure, the person would be getting the same kind of medicine, irrespective of their genetic or genomic properties. Now we are heading towards the next generation kind of medicine, where each person's would be given a kind of prescriptions based on their genetic basic markers or their genetic profiles. So each person is different, so the source of disease could be due to different reasons as well. So now genomic genome processing is becoming more and more popular, but the problem is it takes a lot of time. For example, HPC has to spend days and days to process a kind of genomes. Now, if, for example, if we go to GPs and we ask that please certify our genome, so I mean, they cannot wait for weeks or months, or even it would take years, because the population is too big and the computational infrastructure is not enough. So we were looking for alternative means of processing and representing genomic information, so that we could use AI and we could do more or less processing in real time. So So this is where essentially we tackle the problem at two sides. So first, we wanted to convert the genome processing into a graph. So for example, here, so we broke the genome into a kind of tiles and we linked it to a graph model, and then we put that graph model into in-memory HPC facility. And so the users, when they search the genome, for them this looks like a Google-like search actually. So previously it was taking hours and hours. Now with kind of graph representation and then implementing AI on top of that, we could do it essentially within 2 to 5 seconds actually. So any information, once the genome has been processed, it would take only a few seconds to basically extract the information. Yes, one-time cost is higher, but then the retrospective kind of processing and browsing the data, it would take only a kind of fraction of the time. So this project we were doing with a pharma company, and then one of my PhD students is kind of writing thesis on this particular aspects as well. And we have produced few good papers and few more papers in the pipeline on this particular aspect as well. So now on a similar aspect, so for example, we extended this work and we say, okay, it could not be just genomic information, it could be imaging information as well, for example, diabetic retinopathy as well. So we had a European Commission projects where we integrated all kind of data, for example, lab data, genomics, proteomics data, and a kind of lifestyle, and we wanted to create a whole kind of integrated medical database so that we could extend the work so that this graph or this kind of real-time genome analytics should not be constraints to just genomic, rather clinical, genomics, medical, and all other data should be integrated. So that we could produce a holistic picture of the underlying object or subject actually. So we are still continuing this work, and the data integration is that I mentioned at the fundamental before we could use advanced AI. So. And on the similar aspects, so for example, when we talk about health data or transport data and all kind of other sensitive data or security data, so security is quite key. Trust is quite important aspect actually. We cannot use AI to basically process everything. So now more and more people are using blockchains to first secure the data so that then they could process it. And essentially people are using differential AI or privacy preserving AI or more fair AI or trustworthy AI. So and there are many benefits for that. So for the blockchain, because it's a tamper proof, there are no intermediaries, it's innately secure. So any transaction or any data coming in and going out would be absolutely secure. And it's the reconciled data. Reconciled data mean that there are not different copies of the data scattered around the world. Rather, there would be only one copy of the data, and that would be consistent so that anyone, if they have access to the data, they would get just one kind of source of information. And then basically there are smart contracts that are based on the AI so that when we extract information, there is not kind of human involvement. Both the data ingestion process and the data consumption process are mostly driven by AI models. With that, actually, so we have been working again with a pharma company actually, and few supply chain companies as well. So how can we use blockchain AI to essentially create kind of intelligent healthcare systems so that there is a central golden state of the data, for example. So there is a kind of real-time reconciliations, real-time auditability, for example. We should have end-to-end a kind of a view of the information that's coming in so that we could cut down the redundancies, we could cut down the cost to basically store and process the data. And it should be the data access for AI purposes should be permission. So we should know that which AI algorithm is accessing the data and for what purpose, so that we could have a traceability or provenance both for audit and accounting purpose. And so, for example, previously without blockchain, for example, when there is a clinical trial, they send truckloads of information and the process is quite time consuming. With blockchain, almost each intervention is stored within the blockchain so that when the data is being produced through clinical trials, FDAs and other regulators, for example, they could intervene and check almost in real time, and the AI is working behind the scenes to basically produce patterns and clusters and kind of classifying the objects that are there. So people don't have to wait for months and months before the information arrives. So here with the blockchain, all the compliance process, all the trial management process becomes more or less in real time, and we don't have a data producers, data storage, and data consumers actually. So rather all three things are going in parallel. So this helps actually better in compliance because there is no third party. So FDA knows that the data that is being stored is kind of traceable and it's trustworthy, and it's not has been manipulated or tampered with. So this project, and we are still extending this project. We had a proof of concept with a pharma company in San Francisco, and now we are trying to use the same project with the local logistic companies as well. So because especially, for example, Sainsbury or other kind of companies, they import food from a lot of different providers, and so the food is an important aspect, and so is essentially the clinical trials as well. For example, in here you could see that food adulterations, for example, or contamination is a very important aspect actually. So 1 in 10 people die due to food issues, and food retailers and consumers, manufacturers cannot quickly identify the exact region of the product, and this leads to basically product recallings and all others. So now blockchain here, it would help them essentially to not only ensure data integrity and security, rather they would be able to process the data in more or less real time, because as the data is arrived, arriving. And by the way, all the stakeholders would be using one source of information. There would not be different databases for different stakeholders at different tiers of the supply chain. So this would enable them to more or less quickly identify the source of contamination as well as the source of the products. And this would also basically cut down kind of the red tapes and kind of third parties kind of intervention as well. So reducing cost obviously as we move along. So so both transparency, auditability, and traceability within the food system would be benefiting from the blockchain in AI. So I would stop here and hand over the control to my colleague, Dr. Frank McQuade, who would be explaining the use of AI in digital twins and how they have produced it and what are the applications of theirs. So over to Dr. Frank.
Many thanks, Ashiq. Just a few slides to illustrate how we're taking some of this technology and applying it to industry. I'm assuming everyone can see those slides.
Yes, please.
So Bloc Digital are a company that develop digital twins, Industry 4.0 solutions, really for insight and communication throughout the product lifecycle. So on the following images in front of you, none of them are real in the sense of they're all digitally generated. We have a building from BIM or for sales purposes and architectural visualization. We've got VR training solutions. We've got test data being streamed onto an AR desktop, an immersive rolling road for testing diesel engines, scanning of real-time products, and as I say, we've got degradation of parts on the bottom right-hand side there. So again, it's all about communication, it's all about gaining insight, it's all about enabling people to make better informed decisions. However, the one thing I will say more than anything is these types of solutions can be very, very expensive. Some of them can take years to develop as a solution, especially the training applications. And essentially, they're only really used now by large organizations for enterprise level decision making. However, working with Professor Anjum, what we've been able to do is apply some automation and AI to our processes that allow us to make a step change in the way that we develop digital twins. So on the right hand side here of this is a split engine stand for a Trent XWB engine for Rolls-Royce. On the right hand side here we have an image that it took 65 days to develop. It's an object, it's a fully interactable representation of the engine stand. It was done based on CAD drawings and developed manually. The one on the left-hand side was developed using a machine learning administrator. In our process, we use a number of commercial off-the-shelf tools. However, to get a good conversion from CAD to a real-time object suitable for augmented or virtual reality use, it can take. There are many thousands of options in the way that happens, and it can be very challenging to make that work well. I'm sorry, I've got someone on a call here. Can we go on mute, please? Brilliant, thank you. So the one on the left-hand side, right-hand side 64 days, one on the left-hand side was 16 hours to develop. So we saw an order of magnitude decrease in the amount of time taken to produce this using machine learning, using the AI techniques. Very quick example here. So this is a Trent 900 engine. We were asked to, could we represent some data, animate some data coming from a test bed. We got some, by illustration, I've used a commercially available solution that's IP free. So this was very representative of a Trent 900. Using the automated system, we processed that overnight, 7 hours, 20 minutes to do that. And then we're able to take that, and this is our digital twin builder. This is our in-house solution that we're using to actually create digital twins. We imported into the solution the actual geometry that we've created, and what you can see in the animation in the bottom right-hand side there. We're basically now in the process of connecting that up to data. So we add the data source. We're in a position to go in and select the low pressure turbine system, which is the image you see in the top right hand side there. We're now in the process of adding some graphs so that you can see the data. It takes a couple of minutes, but the one thing I will say is in real life, it takes a couple of minutes. to run through. So I won't sit and go through this in the image, but what we're in a position then to do is have a digital twin specification that we've worked with Professor Anjum to develop that allows us then to take that built digital twin and export that out into a player. In this particular case, I'm showing it on the regular desktop, but that player could go out to your iPads, your laptops, desktops, HoloLens headsets, virtual reality headsets, all about gaining insight. So much information is lost when you just take snapshots and put them on PowerPoint and throw them up on the screen, and then you make very, very large business decisions as a consequence. Whereas if you can actually push this up as a holographic display in front of you as a group and discuss it in detail, interrogate the data, you've got a better chance of making the right decision. But the one thing I will say, using the technology we developed with Professor Anjum, that reduction in order of magnitude is now making these types of technologies available to smaller businesses. The business case is more viable now. We can put forward more training solutions, etc., really aimed at small and medium enterprise solutions companies and supply chains throughout the large organisations suppliers. So that's pretty much where we are. And as I say, the one thing I will say is that this technology is now coming into the hands of everyone based on the use of the AI and machine learning. Thank you.
Thank you very much, Frank. Thank you very much both for your very insightful discussion. If anyone's got any question, please feel free to put them in the chat or join our networking session, please. I'm gonna move into the next session with our next speakers, Dr. Alberto Paganini and Kevin Routledge. And hi, Alberto. Yeah, I'm happy.
Hello, everyone. Okay, cool. Thank you. Just one slide, so it's not too complicated. So hi, everyone, and thank you for joining us here today. I'm here just to tell you in a couple of minutes how you could interact with the University of Leicester and what you could do with our students, because the University of Leicester is really keen. So we are really keen to collaborate with industrial partners to develop projects that can be then solved by our students. This is a great opportunity, I believe, for everyone, because our students are really eager to work on real problems. They want to apply what they learn in mathematics, and in particular toward the end of the studies, they want to use what they've learned, and they want to start acquiring working experience. So because then soon they will be hitting the job market. So if they could work on projects that have real impact, then it is something that they could put in their CV. So there's a lot of enthusiasm on the side of the students, and we as faculty members, we really want to offer them the best we can. And I think it's a really good opportunity to work with partners, industrial partners, who, on the other hand, essentially benefit from essentially a workforce for free. They get like mathematical ingenuity to solve whatever problem they may be facing, and then the students are really capable of providing new insightful solutions for problems that are experienced by real businesses, these being data analytics problems or AI problems or and similar. We really have like a wide range of possible collaborations, and as I said, this comes at no cost essentially to the business partners. If not, what we usually would like to have is kind of a contact, a person who could liaise with our students fairly regularly. Fairly regularly means once, twice a month, just to make sure that the students progress in the right direction. But this is the only thing. And then at the end of the project, students would communicate their results to the industrial partner, so that their solutions could then be implemented in practice. And so, just to conclude here, I wanted to show you 3 ways you could engage with us if you're interested. And these are the 3 ones highlighted on the left. So the first one is something we call the business projects. This is a 3rd year module taken by our students, by our mathematicians. In this module, the students work in groups, so usually groups of 4 or 5 students, and each group works on a business challenge set by an industrial partner who decided to engage with us. And during one academic year, so one academic year means from October to March, the team of students works on the development of a solution for the company, and at the end of it writes some reports, gives some presentations, and communicates the results to the company. And we usually run something like 8 projects each year. And I'm currently, for instance, collecting project proposals. So if you're interested, please get in contact with me. My email address, you can find it here on the right. So this is one option. Essentially getting a team of students to work on your project. Another option is what we call the MMath projects. These are for 4th year students, and these are individual projects. Again, they run for an academic year, so from October to March. And in this case, we usually run like 10 projects each year. And also for this case, we are collecting at the moment potential projects for the students. And so if you're interested, please get in contact. And then to conclude, what we have is another options, which are these summer projects. So at Leicester, we have a master program in data analytics and business intelligence, which is very popular. So we have two takeoffs, essentially two starting points. Students could decide to start either in September or in January. We have 2 intakes, and we have this year we had 50, more or less 50 students starting in September, and 110 starting in January. So we have really a lot of students who want to develop skills in data analytics and business intelligence. And in this master program, at the end of their studies, so after 1 year, students embark in what we call them summer projects, although some of them run in January and February. And for 2.5 months, students work on some projects, hopefully provided by business partners. So this is what they do after they have studied and they've developed all the skills. They put them in practice for 2.5 months, and so we have usually it's either from July to September or from February to April, and these students are really qualified and really know what they're doing. So it's another very good opportunity for you if you have something you need to solve and don't have the resources to do it at the moment. It could be a good opportunity for you to get in contact with us and see whether we can offer these and allocate some students to your challenge. And this is essentially what I wanted to tell you. So again, take home message: we are really keen to collaborate with industrial partners. And if you want to use this opportunity, just contact me at my email address, and I will be very happy to meet with you. And so this concludes my part of the presentation. And now it's fantastic to host one of the industrial partners who worked with us in the past. We have Kevin Routledge. Kevin, are you here?
I am.
Fantastic.
Hello, Alberto.
And who will let us know what he managed to do with our students and how this helped his company. So Kevin, the stage is yours.
Thank you very much, Alberto, and hello everybody. I was just going to give a very brief presentation, just a couple of slides. So as was mentioned, I'm chairman of the Riders, but also a director of the Morningside Arena in Leicester. Morningside Arena is about a 6 or 7 minute walk from Dead City Centre on the Grand Union Canal opposite Abbey Park. It's a community sports arena first and foremost, but it also stages some of the biggest events in Leicester. It's the largest indoor arena, and it stages Bollywood, boxing, snooker darts, and of course basketball. So if we go on to the next slide. So this is the kind of events we hold. On the left there is a Bollywood event. We have a number of them coming up soon. And on the right is Leicester Riders home matches, and we have them starting on the 24th of September. Obviously, we're believing both of those events will be with full capacities, subject to the data we're all seeing daily on COVID cases and the government's reaction to that. Next slide. So our big challenge over the last 18 months of COVID, of course, we've been closed for significant periods of that. We've used that to make all of the changes to make it a COVID secure venue. So the sorts of things we've been doing is, for example, redesign lots of one-way systems, increase concourse area for events, remove all the carpets to make things easier to clean, install sanitization units in various places of the venue, and so on. There's a whole long list of them there. I won't bore you with them because that's not the purpose of today. But it's all about making it COVID secure as we start to see the numbers decline, the government regulations and guidelines changing. Next slide and final. So we've worked with, my background is, I am a mathematician and physicist, building power stations as well as involved in sports. So I'm an engineer, and where we were working with we've worked with both the Innovation Hub at Leicester University and also with the maths department. Pre-COVID, we worked with a ticketing system called Eventbrite. That was the system you use to come to this event. It's an American system that's widely used around the world. We used it, but actually its post-processing capabilities was quite limited. So we work with the university and with a student in the Innovation Hub to do a lot of post-processing work using Excel spreadsheets, using Python, etc., basically to better understand our customers' buying habits. And ultimately that led to a 10 to 30% increase in sales at Riders games as a result of that work. Post-COVID, and we are turning everything we think about into pre-COVID and post-COVID. I don't know whether that's common amongst businesses, but post-COVID we have a new system called Total Tickets. It's not just a ticketing system, so it's been updated for a lot of COVID-related interactions. So we have a COVID questionnaire, we have a COVID waiver, and no doubt with the possibility of COVID passports, we'll be upgrading it further. So that's the main tool for interacting with our customers. It has a much improved CRM capability in it, but like all capabilities, you've got to actually understand it and utilize it. And we're seeing some additional projects for students to help us fully understand that capability and how best to use it in an efficient manner when you've got people working full on with the routine activities of the arena and then planning for these events. And actually we have more events than ever, high profile TV events coming up, and we're going to have to switch on to that as the guidelines ease and we have a lot more people at the venue. So I recommend very much working with the university. It gives you that capability, as Alberto's mentioned. It allows you to do the data understanding that typically you wouldn't have time to do. Thank you.
Many thanks, Kevin. Many thanks for the kind words, and we are very pleased to collaborate with you. And so this concludes this very brief session. Neslihan, I hand it back to you.
Thank you very much. Thank you both for very insightful discussions. So before moving into the next session, I would like to thank all of our speakers today for amazing talks. And now I will hand over to Ömer for the next session.
Thank you very much, Neslihan. So thank you all for the great presentation. So